All right, that looks like we are live. Just check. Yep, we're live. Hey everyone, thank you so much for joining us today. My name is Marty. I'm a lead developer with No More Studios based in Sydney, Australia, where we were founded in 2017. We're a game studio that makes our own games. You may have seen us at PAX Australia and stuff like that in the past. But primarily, a lot of our work now is we do consulting and we assist other studios and other companies with making really cool games. Um, One of the probably most important tools that we've found ourselves using recently for a lot of our projects is Photon Fusion. So we're very fortunate to be able to chat today with Erick. I'll let you introduce yourself, Erick, if you like. And yeah, we'll go from there.
Okay, so I'm Eric from Photon. I work both on Photon Quantum and Photon Fusion, and I'm here basically to answer your guys' questions and chat a little bit about networking in general. Sometimes not only related to our product, so feel free to ask any interesting topic on the subject.
Yeah, awesome. Cool. So we do have some questions that have actually been sent through from our community already. So we do have like our No More Studios Discord, where there's quite a bit of multiplayer discussion in there, which is pretty cool. One of the first questions I actually wanted to start with is actually it's a bit of a well, it's not really a correction, but it was something that in the last video we made on Fusion, something that's changed sort of in the meantime. So Erick, I wanted to sort of ask you for Photon Fusion specifically how WebGL developments and WebGL games are going in Fusion at the moment.
So it was since the beginning, it was a requested feature because we have a lot of people working on WebGL now, especially because of all this Web3 things going on. And of course, we wanted to support it, but on the first versions, it was not there. But I think when you produced the video, maybe the version you got was not yet with it. But soon later, we added WebGL support, and it's now being used by many studios, so you can just use it. So there's not a lot to add. I mean, it should work normally as any other um, uh, platform, and we support it both for client server versions and for shared mode as well. But the only specifics about it is that when you're using a WebGL client, it will always go through relay. So in shared mode is always going through the Photon Cloud, the whole communication. But even on client server modes, WebGL clients always going through the relay. That's the only difference between the other stuff. But all the APIs are available. I mean, anything you can do on the others, you can also do on WebGL.
Yeah, awesome. Yeah, I'm pretty sure the WebGL update dropped literally like a day or two after we recorded
After
that
your
last
video,
video.
yeah,
Yeah,
yeah, it's
unfortunately,
it's
but
been up for a while, and a lot of people are using it now. So it's no.
awesome. Um, it's actually really interesting because you touched there briefly on obviously differences between like shared mode and like client host, like different topologies there. And I'd love to sort of chat with you a little bit on that sort of topic, and just sort of dive into, I guess, looking at it from the perspective of the different sort of topologies you might look at using for different kinds of network games. And specifically, we can touch on like the differences between say fusion and quantum for that and yeah, sort of what decisions you might be looking at early on in a project. And I've got actually I can screen share this, which is the quadrant, which we refer to quite a bit. This one here. Yeah,
Yeah. So this is for me the most important question, right? So which is um, these early decisions you do. There are two early decisions you have to do. The first one is that when you're planning to do a multiplayer game, the most common mistake is to, oh, I'm gonna start here as a single player game, and then I'm gonna add multiplayer. Um, so this is the first mistake people do because uh, it's a lot it's a lot more difficult to get a single player game and turn it into a multiplayer game than it is the opposite. So you should actually do the opposite, which is you start with multiplayer right away, and it's like single player is like a subset of what we're doing. We're going to use the same code. Normally all these different netcode SDKs allow you to also run single player. Ours is not a different. Is not is, For ours is not different. So then it's okay to prototype very quickly on single player, and then move to multiplayer. But as soon as you start really doing the game, go for multiplayer right away. Then the question is, what should I use in terms of network topology or even more general architecture? For example, in our case, we have Fusion, which implements state transfer, and Quantum, which implements determinism. These are two fundamentally different approaches for doing networking. And without going into the details of each one of them yet, uh, what I'd like to start with is that it should not be a matter of a personal choice. There are cases in which you may have a preference for one thing or another, and when the case actually allow you to choose between different things, really, then it's okay to have personal preferences. But and of course, something that matches the team experience and so on. But in reality, what you should do is you should take a look at your game or application, what you're doing, and it will tell you what it needs to use. What do I mean by that? It's that certain gameplay mechanics, they fit better, or patterns in terms of how many players you need to have, how many moving units you're going to have. That's going to tell you how much data you're going to have to transfer if you're using state transfer, or what is the limitation on the size of the thing you're doing if you're using determinism, and so on. Um, so the gameplay mechanics are going to tell you what you need to use. And the second and also super important aspect of this is that when you release a game, you have to pay for infrastructure. And a multiplayer online game, you have to pay for infrastructure. So the other super important aspect is the cost efficiency of the architecture you're choosing. So um, you may think, oh, I'll just go for dedicated servers. But dedicated servers are very, very expensive to run because you have to host somewhere a full engine headless instance. And that's, for example, a lot more expensive than running something in shared mode. I'm not saying that you should always use shared mode, please, but it is important that you understand the differences in cost. And this is independent of if you're using our stuff or using something else. It's really about the choices you do in either using dedicated server or letting a player host a game, or even running shared mode or relay stuff if you're using other technology, or going deterministic in our case with quantum. So cost efficiency is the other super important aspect. So if you're planning to release a free to play game on mobile, cost efficiency is super important. If you're doing an indie game that could play well with a player being the host, like you have games like Valheim. So these are always player hosted. So this is also cost efficient because you are not paying for the server. The player is actually hosting the server for you in his own machine. So these are a lot more cost efficient than running dedicated servers. So there is a place for dedicated servers, competitive stuff that you have to have full control, which can also be done with quantum without running dedicated servers, right? But that goes more into the different game mechanics, that should I use either state transfer versus determinism. But this is the overall picture. First is what gameplay mechanics you're using. We're going to comment a bit on those. And second is cost efficiency. These are the important aspects for you to choose. It's not personal, it's about what you're doing.
You mentioned how the primary difference between Fusion and Quantum was obviously Fusion being a state transfer based networking stack, whereas Quantum is obviously like more of a deterministic stack. Can you go into a little bit more detail on I guess, what those differences really mean and how that may affect the decision making process for developers?
Sure. Let me see what I have here. Okay. Mm,
We didn't
I
prepare
was
enough
thinking about
we didn't
I
prepare
was
enough
trying to get
prompts
some
to yeah.
props, yeah, but I'll use these. Okay, so if we're running a multiplayer game, what matters is this. So the set of game objects you have with their properties, their fields. Let's call that the game state. So building a multiplayer online game, basically what you have is you have multiple computers that are connected somehow, and you need to make sure they have a synchronized game state. It may have a subset of the game state, it may be the whole game, it may be a subset, it may be the whole game state. But the goal is to have uh, the same game state on all the machines, at least the parts that you want to be seen by everyone. You do not want to have something like this, so games are disagreeing, right? So this is the goal as a developer. You want to have same stuff on all machines. So there are two fundamental ways to do this. One is you either transfer the game state itself, so you keep copying the data from either one server that transfers to all clients, or somehow you let this guy control part of the game state and send it to others, and this guy controls the other part of the game state and transfers back to others, and so on. But you are transferring the game state itself, the liquid here. This is what I mean by state transfer. You're transferring the object data. The other approach, which is determinism, is you you somehow have a control point, a server, but it does not transfer state about the game objects. What you do is you make sure all your data structures and algorithms are deterministic, meaning that with the same initial state and the same code and input running over time on a tick by tick basis, you end up with the same result. This is determinism. So if you can guarantee that, there is a very, very efficient way of doing networking, which is you only transfer from the different players their intentions. So this player here, please focus. Yeah, this guy is transferring not the content of the bottle, but transferring just the inputs that the player is doing. And when the input gets to this machine and to his machine as well, it will be simulated with the same algorithm and based on the same previous data, so you will reach the same results. And you may think, oh, but that's slow because you have to wait for the input and so on. We're all familiar with, let's say, the concept of predict rollback, which means that you can always locally predict multiple frames in the future, and whenever you have the confirmations, you roll back, resimulate to fix all that. So that's not a problem. So that's a concept that's been used on fighting games since ever. So that's what quantum does. So it's not a lockstep old school determinism, but predict rollback determinism based on a server. So this is a fundamentally different way of doing multiplayer. Uh, it's super cool because as a developer, you do not even have to think about transferring data. Forget about RPCs or state transfer. You just implement your game and it works multiplayer. But on the other hand, you cannot use Unity as it is because Unity is not deterministic at all. You cannot use physics because it's not deterministic. So you have to use something else. You either have to develop something yourself, or we offer a full game engine for which is quantum. But which one to use depends on what you're doing.
Without going too far down the rabbit hole of I guess the benefits of fusion versus quantum and stuff like that, because that could easily be a whole other
Yeah.
multiple hour video just on its own. I know earlier today we were touching on a few of the like big benefits of a deterministic system, for like say for like if you're using quantum for like a multiplayer and single player game. Can you just very briefly sort of touch on like the benefits for say things like replays, local players, those sort of things?
Yeah. So the big benefits of determinism are, it's once you learn the API, which is specific to quantum and the engine, you see that it's a lot easier to maintain the code in the long term because it looks a lot more like a local game. You don't. It's less complex. The code you implement is a lot less complex. You also gain. You get full replays and also kill cam style replays for free. Um, these are some of the big benefits. Something that's particular to quantum is the strict separation of what is gameplay simulation and what is view. So that also pays off in the long term because helps maintainability, but that's a particularity of the model we chose for quantum. Um, but these are big benefits of using determinism. It's also interesting that with deterministic physics, doing predict rollback like we have, because we have this uh, um, purpose made stateless deterministic physics. It's very good for physics sandbox games, which is because if you see in Fusion, which is state transfer, we also support predict rollback, right? So Fusion is also predict rollback without determinism based on state transfer. So we try to have feature match between the two products. They're both tick based, they're both predict rollback. They're very capable of doing the same things. It doesn't mean they are better, they're equally good in everything, because I'll give the example of physics, because physics is in Unity is a great physics engine if you're doing a forward only thing. It's also not normally a problem if you're building a shooter, because on a shooter you do not have really a lot of physics interactions. You have character controllers, you have projectiles, and these are somehow, they have a somehow established way of being done that matches the way players expect to play these games, um, in a way that's fun. Uh, but if you're trying to do a physics sandbox game, physics is not really well suited for that, because for that you need full predict rollback, and physics becomes expensive to do predict rollback, because every time you reset the state of rigid bodies on physics, it crawls to a halt if you have a lot of them, because it has to rebuild the, broad phase data structures that were not built for that. Our physics engine, on the other hand, for quantum, is designed for that. It has disadvantages compared to physics in several aspects, but rolling back is not one of them. So you can freely roll back and the performance is not going to degrade. It's actually always rebuilding these data structures anyway. So it's really good for doing this thing. So this is another example of something that is really well done if you choose that can be really good to do in a deterministic engine like quantum. It's a physics sandbox kind of games. I think I kind of lost the question exactly. So if you could remind me, I got
Uh,
into my
it,
rabbit hole and
it was basically where we would look at like choosing between state-based and determinism.
yeah. So this is one example, right? So if you're doing something that's more like a physics sandbox kind of thing, uh, the limitations you get with determinism are kind of well known. So a couple of them are, first, you um, you have perfect information. So if you're doing something like a card game where you do not want people to be able to, with a hacked client, see what's on the other player hand, you are not going to go for determinism, because player hands are part of the game state, and it's kind of difficult to protect against that with determinism. That you do easily with state transfer. If you're running a dedicated server, you can easily selectively send data for each one of the clients. But this is kind of overrated as well. I mean, a lot of games can just do with that, and there are other ways to protect this kind of thing. And the point is, it's really about what you're trying to do. And so there is an interesting case, which is if you're doing a MOBA, like kind of like League of Legends. It's interesting because Heroes of the Storm is done with determinism, whereas Dota and League of Legends is done with state transfer. And this has nothing to do with them being successful or not. So you can do, it could be equally successful. The reasons for success are different ones. You cannot say that the game plays bad because of one or the other, right? So they play. It's an interesting example. It's a MOBA that you can do with either kind of like equally well. And but the other drawback you have is it's kind of difficult to argue to do an open world survival with a very big gameplay world with determinism, because every single device has to be capable of simulating the whole game. It's I'm not saying that one particular person with a bad device or a bad connection is going to impact the other players. That's not the case. Quantum fully protects you against that because the input management is server based. So if one guy is struggling to keep up, he's going to have a bad experience and he may even be disconnected because of that. But the others are just playing normally because there is a server in the middle guaranteeing the input stream. So it's not what I'm saying. What I'm saying is that, yeah, for that guy, the game is just not going to play well because he doesn't have a device capable enough, because maybe the developer went too far and developed something way too complex to do with determinism. Um, it's not, and then you say, oh, but is it as easy as, oh, let's move to state transfer? No, I'm talking about cases where even doing a state transfer, you have to be careful. You have to make sure you know your CPU budget on the device that's going to be the server. You have to be very careful with um, interest management to send data to the clients, only data that matters, because you can easily get into bandwidth issues. As efficient as Fusion is, if you make a big enough world constantly changing everywhere, it's too much data to transfer all the time to all clients. So you have to send selective data. So these are the cases where you normally do not go for determinism. So you just go for state transfer. If you're doing a competitive shooter, just go for fusion as well. There are a few specific things like animation is a very very interesting point to discuss, because I'd like to touch on the first let's say kind of strong opinion here. So there is a lot of emotions and bias involved when people choose tools and so on, and people like to recently to talk badly about Unity in certain aspects, and I'm not going to get into the details of all those things, but one thing I particularly like on Unity is the fact that playables exist. Playables, the Playables API. I'm not gonna discuss on how good it is internally, how better it could be, but the fact that the Playables API exists, which lets you have different animation clips, blend them in with your control. You know how you set how much blending you want at any point in time. You can set the exact timing for each one of the animation clips independently in a Playables mixer. That's very powerful control. So for and the polemic point here is that, did you guys know that Unreal does not have that? So if you try to do tick based, tick accurate animations on client and server in Unity, you can with Playables. If you control that, that's what we do in our Battle Royale sample in Fusion. If you go for Unreal, that kind of control is not so easy to do. I have a visitor here. Luna, eu não posso falar.
Hello.
Okay. 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 Back here. So you cannot do that as easily in Unreal. Funny as it is. So Unreal is great, has other advantages and stuff. But people like to bash Unity. But just the fact that we have playables, it's much easier to start doing tick accurate animations, for example. I'm not an expert in Unreal, but I got some opinion from other people. You can do tick accurate as well, but it's not as easy as it sounds. And then I brought this point in because when you want to do a highly competitive shooter and you want to have you want to trust the results. If you're doing client server, you wanted the server to be the only authority on the shooting. And yeah, we do have lag compensation in Fusion. We could add lag compensation to Quantum, but because you have tick accurate animation control with playables, that's a very powerful tool to do very accurate shooting. And that, if you want to do that with determinism, you would have to implement something like playables yourselves, right? So for a fighting game, it's easy because you only do linear animations. You do not blend in a lot of stuff together. But when you do a shooter, you have a lot of blending. So just to comment, that's an advantage of doing state transfer. Let me quickly check here if we have important notes on our Discord. So
We've got
these are
a,
questions. I'll let you guys handle which
yep,
ones will be asked. Okay.
yeah.
So
Um,
this is an interesting point where state transfer pays off really well, which is you you can use some of the good things Unity give you, and that could influence gameplay. And the Playables API is one of them. I would not like to extend that to Mechanim. Mechanim is not good for that. Mechanim does not allow you to control timing at all. It's a good enough animation tool if you want to have what I say poll based animations, which is you have the game state and you derive the animations from there. But if you want the animations to impact gameplay, you must go for Playables. And but the fact that you do have Playables is a great thing in Unity land, let's say.
yeah, that's awesome. I actually didn't know about syncing with Playables. So I know someone in chat just asked, like, are there any resources for using the Playables API with Photon? I don't think there's
We're
anything specific.
preparing we're preparing some primer. So we have a an animation primer documentation entry that will touch on the playables and give a few examples. We'll have a bit of a sample. We're discussing what we're going to include or not on that. And our Battle Royale sample, which is available for Gaming Circle subscribers, have a fully fledged playables based animation sync in that we have absolutely full control of tick accuracy. So if your hand was like this on the client on tick 473, it will be exactly like this on 433 on server. And when you see 473 as a snapshot interpolated frame on your end, it would always be like this. So if you shoot me in the hand, that's how the server is going to compute it. So we have that kind of control with playables. And yes, we're going to share a few more things. So they're not live yet, but it will be over time. We're going to have more and more stuff going live with
Yeah,
them.
awesome. You mentioned there just quickly Photon Circle, and I'd love to get you to just go into a little bit of what that is. And because I mean, I guess a big question that people would have based on what we've discussed so far is if they are at the point in their project where they're trying to decide between Fusion, Quantum, or other stacks, where the best place would be to reach out to get help in making that decision or to chat with experts.
So
So yeah,
let me quickly explain what gaming circle is. So what we found is that um, it's very beneficial for the teams building the games that they start very early on. That they start very early on doing the multiplayer part, and that means that we wanted to give, especially studios building bigger projects, or but also smaller cases, a better access to us. And that the answer was gaming circle. The reason we did this was that we have the experience with quantum that has always been exclusive to people who subscribe to access it. And what you get from this is basically you get into a private Discord that we have, where the core developers of the engine are. Uh, so if you have a question about something, you're going to talk directly to the guy implementing that feature. We don't have layers to of supporting there. And if you want to request a feature, we immediately consider. Sometimes we add it on the next day. So if it's something that's a no-brainer, simple thing to add, it will come on a nightly build right away. So that's what Gaming Circle is. It has different tiers, and basically you get immediate access to the core development team uh, on a daily basis over Discord. You have access to some exclusive samples. So, for example, the Battle Royale Fusion sample is um, only available for Gaming Circle right now. Uh, One important thing to mention here is that the version of Fusion you get from as a gaming circle subscriber is the same version of Fusion you get publicly. So it's not a crippled version of the API or anything like that. And we are considering also releasing Quantum with a free for development in the future. We, as always, we never have ETAs or even guarantees that it will happen, but we have been considering this even more strongly now. And if it happens, it will be the same case in that, yeah, it's the same version of that everybody else in Gaming Circle has. But Gaming Circle gives access to us on a daily basis. I mean, the core guys doing the engine every time, all the time. And yeah, we
Yeah,
have
awesome.
even individual plans that one developer can subscribe to it, or but for what 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 even a small studio uh, many found is that the price for this it's really like having a developer at your side. So it's a lot cheaper than actually paying for a dedicated network developer to do some things that the tool can do. And especially in the case of Quantum, that has been a no-brainer for all the studios using, because when you use Quantum, you basically, if you had a network developer, this guy is not anymore uh, needed for that task. But I'm not the network developers are normally very good developers, right? So what happens is that when using some things like that, this guy can shine and either be super much more efficient, or be a great gameplay developer, or he can cover backend development. So these are very good resources you have. And what you get when you use these tools, and especially with the gaming circle support, is that these guys can really excel and do much more. So this is what studios found, that they can make much better use of the restricted resources they have by paying this fee that is a lot less than hiring an extra or other guy. I'm not saying that they're gonna let someone go. No, they're gonna have this guy be more efficient and do a lot more things.
I know one of the big things we found with like Circle membership was that like in compared to the overall cost of development and running a live multiplayer game, the Circle membership was like cost basically nothing in comparison. So yeah, it's
Yeah.
definitely something very much worth its value. Um, but yeah, there's a couple of questions coming through I think are quite interesting from
Hmm.
uh, the comment section. We will try and get through as many of the questions as we can, obviously. If we aren't able to get to your question specifically, obviously feel free to jump on the No Moss Studios Discord. I think Anne might be able to throw a link in the
Or
comments.
our Discord as well, so we
Or
always
yeah,
try to answer the questions. If you have something very important, send us an email. Emails are registered. We never lose them. We have a ticket system to make sure we answer all of those. So
Um, so one of the questions that came through, were there any kinds of games that you think weren't possible or would have been difficult to implement with Photon before Fusion that would now be a lot easier? So I guess the question there is games that maybe weren't possible with Pun but would now be possible with Fusion.
I mean, it's a super interesting question. The thing is, uh, Pun was is it's still alive, and it's still been getting bug fixes, just not receiving any new features. Pun is great. It's a great tool for you to start and to learn multiplayer and to release games. There are so many success cases done with it, but it has its limitations. Like Fusion also has its limitations, or Quantum has its limitations. Every tool has its limitations, right? It has its strengths and limitations. But yes, there are things you cannot do with Pun that you can do with Fusion. But they're not like, I mean, it's not like you cannot do a shooter with Pun. You can, but you're not gonna be able to do proper lag compensation. You're not gonna be able to do uh, actual snapshot interpolation because Pun is not tick accurate. Actually, most of the networking tools are not. So what we have with Fusion and with Quantum, with this thing about tick accuracy, is thing that normally only AAA studios doing a highly specialized game have. So this is the kind of stuff that you see on Counter-Strike, on Overwatch, on Valorant. Fusion's networking model is very similar to the one Riot implemented from scratch for Valorant. The tick model is exactly the same, discrete ticks with discrete inputs, and so on. With only clients predicting rollback, the server only rolls back lag compensation, it doesn't roll back state at all. So it's very similar. But so what you can do is like you can do these highly accurate things. So if you take quantum, for example, just take Stumble Guys, which is, I mean, on the newsletter we're stating publicly, it's a game with 800,000 and plus concurrent players. It's 20 million daily active players. It's numbers you can't contest. That's done with quantum. So a lot of its success is because of the physics accuracy of the interactions you have. So you see these highly skilled players dodging and blocking each other and commenting on streams that, hey, he blocked me right away. And that's the kind of thing you can do with physics accuracy that you could not easily do with pun. And you just get that out of the box if you're using something like quantum. And fusion, okay, I agree with you. Yeah, and so and for fusion, for example, you have the stuff like shooting accuracy and so on. Yeah, Dora was opened by the other kids, so this one sneaked in.
All
Yeah,
good, all good.
so you have this accurate shooting is something. It's it just feels much better for the player. The game is a lot more snappier, and it's actually easier to implement as well. You have less work to do to get these super accurate things. And other example is you can crank a lot more data. Even let's put quantum aside because quantum is deterministic and the amount of objects you have doesn't really matter for the networking because it's only input going up and down. But in Fusion, you're still transferring data. But just the way the state transfer is done, that's much more efficient. And the fact that it has built-in interest management, even in shared mode, which is the client authoritative mode that's very similar to how PUN works, uh, Fusion has built-in area of interest-based interest management, meaning that if you're not close enough, you can decide the areas you are interested in getting data from, considering network transforms. So if you're not close enough to a player, you're not receiving data about it. So that lets you scale so much in the amount of stuff you can do, even in shared mode. So you could not do that with pun, that's a technical feature. But essentially, you can put a lot more players into the same session. So right away, our flagship demo in Fusion in client server mode is a 60 ticks per second, 200 player shooter. So you have games done in Unreal with 100 players at 30 hertz, 30 ticks per second, and we're talking about doing 200 at 60. How much can you do if you reduce this to 30? I don't know, 400, 300, depends on your game. What if I reduce to 20 hertz like some of the Battlefield games? Maybe 500? I don't know. The limit is not defined by us. You can experiment. And in shared mode, how many players can you crank it up in there? I don't know. Depends on the on how spread they are, how frequent you do the updates, and so on. You can go a lot higher than you could do with Pun.
Yeah. I mean, just to clarify, we're not saying that anyone can jump in and do a 500 player battle royale out of
Yeah,
the box.
no.
Yeah.
Yeah,
But
that requires some work, especially just to forward that on a Unity client, on a Unity's dedicated server, just to have that steadily going forward with Unity. It's a lot of work, and especially if you want tick accurate animations and so on. But it is possible, yeah.
there's a couple of questions just have sort of come through on like a similar topic. One was what would be the best solution to implement like an MMO? The other one was which would be the best option for like a Unity WebGL open metaverse. Um,
Oh, Unity WebGL Open Metaverse depends on what kind of transactions you want to do. If you have if it's more like user interactions that are more free, etc., I would say you should consider doing shared mode because of the efficiency. It's much cheaper to run because you don't have to deal with dedicated servers. So I normally recommend, if you're doing a social hub kind of thing, go for shared mode. It's very cost efficient. Even for if you're doing a shooter or something like that, if you have a playable lobby at the beginning or something like that, that you're just hanging around with other people, and then a subset of those people are going to go into a match, I would say it's easy, it's cool to do that in shared mode, because you don't have to host a dedicated server for that. You just run over our cloud with just the CCU pricing, and then as you go into a game, you can even run dedicated servers. Then the question, so for depending on what you're doing on a shared experience kind of social hub metaverse, I would go shared mode. If you're doing something that has financial transactions that are done implemented by the gameplay, then you should consider dedicated server. That's the thing. If you're doing an MMO, it's people have different definitions of what an MMO is. For me, an MMO is something like a World of Warcraft or Eve Online or Albion Online or these bigger things. And the answer for that normally is don't do an MMO. If you're asking this question, it's because you don't know what to use, which means you are not yet capable of doing an MMO. Because the technical answer is an MMO involves a lot of different tech stacks. You're not going to use a single tech stack to do a big MMO. You're going to use state transfer in a certain mode for the overworld. As soon as you get into a battle, you're connected to a different server to control that battle. If you go into a raid, it is normally a different networking architecture to go into that raid and so on. So Fusion is definitely capable of implementing all of these individually, but to make that a complete MMO thing, it's a lot of work to have the individual pieces, and definitely it's not something that you get super easily. But some people consider an MMO a game that you have 400 players connected running at 10 ticks per second. Yeah, that you can do easily with Fusion. So, but you would run a dedicated server, right? So don't expect to call an MMO something you host on someone's machine. Um, but that's an interesting question because we are working on something. I can talk about it briefly that will go towards that direction that's more specialized for bigger games and worlds. But we don't have much public information about it yet. But I can say it will be based on Fusion, and we'll announce it at some point, perhaps this year still. And yeah, but as it is, with all the features you see Fusion has and what it can do, you can definitely combine different implementations of servers done with it to do a proper MMO. And if you mean an MMO is just a hobby game where you were expect to put 400 people in an instance in a shard, yeah, you can do it now.
So I guess, yeah, like obviously what you just alluded to there, we can't really touch on too much, but if someone was looking to maybe use Photon down the road for a large scale game, maybe as an interim, if they were to learn Fusion, that would definitely put them
Yeah.
potentially in a good spot. Um,
Yeah.
without going into too much detail, obviously.
I mean, learning Fusion is good to prepare for that, but it's also a good way to learn networking in general. Fusion implements some networking concepts that no other tool does. So at least, I mean, no other off-the-shelf tool does. Of course, other games have these features. These are state-of-the-art standard practice in competitive games, for example. Uh, I'd like to kindly request you, Mari, to get the last question if you want, because it's very interesting.
The one
Last
about
one on.
the dots ECS
Yeah,
one.
yeah.
Yeah, yeah, cool.
Okay.
Uh,
S- mm.
so the question is, it's basically dots. It's basically talking about how ECS and dots is obviously a super efficient system that Unity is now sort of starting to support. How does Fusion or Quantum play with Unity's dots architecture?
So first, I'm gonna uh, split what dots is. So dots is an acronym for several different stacks Unity is building. For a tech stack with several different pieces that Unity has been building for the past years, okay? You have on the dots thing, you have job system, the system to handle parallel tasks. You have the burst compiler, and you have the Unity ECS, which is the biggest part of it. So I'm going to comment on these all separate, right? So first, burst and jobs have been production ready. Of course, they still have here and there bugs, as everything everybody does, right? So I'm not complaining about. So these have been production ready. So they've been used in a lot of stuff. Unity ECS has never been released yet. They're promising a 1.0 now, but there is also the fact that a lot of us are not 100% sure that's a good direction to go for the general Unity public, the Unity ECS. There is also some different choices in the ECS architecture done. So they chose for the archetype, which is yes, the one that can do more with the same amount of time, but it's also a lot more difficult to work with it. So there is the Unity ECS, which is not mature, it has changed a lot, and it has never been released for production yet. So what do we do with those? So in Quantum, we use the Unity job system to drive the threads on the clients. Very lightly, just very broad face, because we have our own task system. We could also use our own thread management, but we use jobs to trigger the threads. It's been fine to use it for that, with a couple of quirks here and there, but we've been using it in production. Stumble Guys runs on that, so we have job system, so we use that from dots. Quantum is an ECS, but it's its own production-ready ECS. We use the sparse set ECS model, which is fundamentally different than the archetype ECS architecture Unity uses. It has nothing to do with each other. So the only common thing is that they're both entity component system architectures, but they're totally different implementations, even philosophically different implementations. The difference is that ours is production ready, has been shipping games, is the same model used by the ENTT, which is the ECS that was used in Minecraft and a few other things, the C++ version of it, I think. Then the Unity ECS is something else, right? So we never used it. Fusion optionally uses the burst compiler. If you're using delta snapshots state transfer, you can ask Unity to use the burst compiler to implement to compile the compressor for the delta snapshots. So we use burst in Fusion, but only if you're using DS, which is the version the state transfer version that's less common, because it's really suited only for a super high frequency, let's say 120 ticks and plus, small competitive game. Everything else you should be using eventual consistency, which is EC mode anyway. So we do use those two. ECS, no, we don't use at all. It would be probably possible to use later on when they release it, to use Unity's ECS to integrate Unity's ECS to Fusion, including their physics engine. We're looking into that at some point, but not yet. And I'm not sure that is even a good direction for the general public to do. I mean, we have a reason to use an ECS architecture in Quantum, which is Quantum requires you to be as efficient as possible to be able to do predict rollback and resimulate everything. But of course, that comes with a cost. Training people and people developing with an ECS architecture is not as common practice as the millions of Unity developers out there accustomed to the game object component world. So it's a departure from that model. So we're not sure that's good for the general Unity, but let's see.
Yeah, cool. That's really interesting. Um, I wanted to circle back. There's a few other questions. I just want to make sure we try and get as many of the questions without missing any. And I want to definitely save some time at the end because there's a topic that I really want your opinion on, and I think you and
Yeah,
I
I'm
have very
thinking about that topic and I'm looking at the time. So
yeah.
make
All right.
sure you don't forget about that one.
I haven't forgot that one, mate. So just really quickly, I wanted to touch on what voice support is like currently for Fusion and
Okay.
Quantum. And the second part of that, which one of the questions from the chat, will there be a voice solution for WebGL in the future?
Okay, so these are two questions. So first, most people know that we do have a voice product. The thing is that in basically every game you have, voice communication does not go over the same connection as the gameplay simulation. Voice is normally a separate thing. So you use a separate solution, it's even a separate connection and all. So we would not add built-in voice into Fusion because that's not the right way to implement voice. Voice is streaming, is unreliable streaming of binary data, which is a different way of doing stuff. We already have a product doing that called Photon Voice. And do you have to use Photon Voice to have voice in a Fusion game? No, you can use, if there is any other voice solution that has a infrastructure to run voice connections and so on, you can surely use that. We are agnostic to what you're using in that sense. The point is that you do not pass voice over gameplay data connections. These are two fundamentally different problems that require different solutions and different ways to tackle the data transfers. So knowing that, both Quantum and Fusion are fully compatible with running Photon Voice on top of them. So that's what we recommend and that's what people do. They just use Photon Voice integrated to Fusion. We even have a sample for that's being maintained. So the guys been improving on it. So the Photon Voice team has been working on it a lot recently even. So you can just take these examples and start from them, or you can use something else if you want to, although I do recommend you checking out Photon Voice for that. For WebGL, it's a long requested feature. The guys work on it, but as always, I cannot share ETAs. And this is the kind of thing that's better if you ask us over email, because you would be put in contact with the Photon Voice team and the guys who do the decisions, and they can give you a bit more details about, or maybe they can share when or if this is expected. I'm not part of the voice team, so I don't know the details about it. But I know it's a common request, and I know we do not support it as of now.
Cool. Um, awesome. Which brings us to the interesting question of the evening. Um,
Hmm.
so I would like to know what your thoughts are on RPC calls, specifically within Fusion, but just
Hmm.
in terms of network architecture in general for a multiplayer game.
You made such a hype that people may be disappointed that this is the question, right? So, what is my take
I
on RPCs?
yeah.
I hate RPCs. That's my take. I think the problem is that I think RPCs are overrated. People tend to think too much in RPCs, and RPCs are a tiny, should be a tiny portion of your stuff you do on a networking game. And I'll explain why. So I like to explain netcode SDKs with their capabilities, explaining in layers, right? So if you think about, the most basic layer you can have is a transport layer. That is something that means you can send byte arrays. So let's use some props. So you have a transport layer here that sends data around between peers, either a server, a client, or multiple clients, whatever. Then I like to say that some solutions are on a second layer because they add a little bit more to these, which is, oh, these different solutions, they're interesting because they let you think about objects, and it serializes objects for you and somehow transfers these objects for you from one machine to another. Which solutions are in this layer here? You can think of Pun, you can think of Mirror, Unity netcode for game objects. They can do this. They can transfer objects for you around. Then you have an even better, more interesting layer, which is a gameplay based layer that tells you how to implement the simulation and controls you tick accuracy, gives you snapshot interpolation, lag compensation, all out of the box. If you do things right, control how you play with the inputs. That's the highest possible layer you can have of features that you do not have to implement them yourselves. And the thing is that when you get one of these, it may be very difficult to do this thing here if this part here is not done efficiently planning for this. So it's not like you can get one that does this and, oh, I'm going to add my tick based layer on top and my lag compensation on top. It may be very difficult to add this if this layer here, pun, for example, was not designed for this. This is why we design a different thing to do this, because this version is not here. So what this has to do with RPCs? Because RPCs are not even this. RPCs are between these two. They're here. So what RPCs are? They are a transport layer with a little bit of structure, which is you can pass parameters on a method. So when you choose to do a lot of stuff with RPCs, you are choosing to ignore what these things do and ignore what is being done for you here. And you are trying to design it yourself, basically by relying on a transport layer that is convenient because, I don't know, especially on Unity land, people tended to rely a lot on doing stuff with RPCs. But this is one way of explaining it. I'll do a second way. If you do RPCs, you can forget about, if you transfer data from a server to clients using RPCs, you can forget about late joins. RPCs do not stay forever. They are ephemeral data transfers that if somebody joins late and you changed something on the clients based on an RPC, this guy who joins the game late or who reconnects does not receive the RPC. So he doesn't have that data. It's lost forever. And then you may think, oh, but I can't transfer to the guy who can. See what you're doing? You're trying to implement what we already did for you with state transfer, which is if you put data on state and somebody late joins, it is transferred for him. That's it. You don't have to do anything. Why do you have to try to implement it yourself? And RPCs do not have tick accuracy. They are less efficient. They do not have specialized on change. They do not have snapshot interpolation. They do not have the same kind of compression you have of transfer on change only. You lose all of that. But then why do we have RPCs in Fusion? Because there are valid use cases for RPCs. I'll give an example. So I'm playing Counter-Strike and I'm here, I want to buy this weapon, I want to buy ammo, I want to buy Kevlar. How do I communicate my choices to the server to change my game state and equip me with Kevlar? So equipping with Kevlar is adding some data to my network data on the server and transferring to everybody. How do I tell the server I want Kevlar? I'm not going to use the regular inputs. That's for intention controls. That is the exact case I should use an RPC. So from the client to the server, I want to change my loadout. That's a good case for RPC. You send directly to the server with your choices. Another case, I'm looting this thing and from the bag I have here, I want this and this item. Send that as an RPC and the server implements the validity checks if somebody else did not get it before you, but it does that and changes the data on the server itself. So it's normally from the client to the server, the valid uses for RPCs. Initial loadout, changes on loadout, choosing a loot thing, and you can, in different game genres, you can of course think about the equivalent cases. But then there are occasional cases in which you can send from the server to the clients, mostly unreliable RPCs for triggering effects that you cannot derive automatically from the game state changes. But it must be things that it's okay to lose. So if it never arrives, it's okay. Maybe the client's going to miss a visual effect. That's the only thing that will happen. So that's another use case for RPCs. And you think, oh, I wanna generate I wanna procedurally generate something and transfer from the server to the client, like a level. What should I use for that? RPCs? No, we have a reliable streaming API for you to do that. You just push a byte array from the server, you're gonna receive it in order on the clients. And you can reconstruct your data. It's reliable. So that's what you should use, not RPCs. So that's my problem with RPCs. I know some some networking stacks are implemented on top of RPCs, but that's a different story, right? So the network stack itself does object transfers, and okay, if the RPCs are efficient, you can do that's a choice that was done to do that. The problem I have is not with that in itself. I know some people have problems with that. I'm not going to comment, but my problem with RPCs is when developers of the games themselves, like the game developers, start to overuse RPCs because perhaps it's our fault. We should document better that it's much better to use state transfer for 99% of the cases, and RPCs are really, really rare to be necessary. And I'm kind of on a crusade to do that, which is to, guys, please, RPCs are good for certain things, but they are not the base of any implementation. There is another exception in shared mode because there is no central server authority. Sometimes you have to ask the authority of an object to change something, and then you're in shared mode. You tend to send a lot more RPCs, but it's always this pattern. You are asking the state authority of a certain object to change something because you cannot change yourself. So if I'm in shared mode, if I shoot at you, Marty, I cannot change your health. I have to ask you to change your health because I shot you. So I could either transfer a bullet and let the bullet be computed on your side, or I can request something to change on your side. But I'm giving a poor example because if you're doing a shooter, you should not be using shared mode. You should be using at least player hosted, right?
I was
That's
going
my
to
take.
say, in that example there, where you're asking like my state authority over like my player object to change health, that opens up a lot of potential vulnerabilities for hacking and all sorts of issues there. If a client is able to directly ask another client to change their health value and stuff like that.
Yeah.
Um,
And
I
the
think
last thing is I'd like to say that half of this is my personal opinion, right? uh, Developers are 100% free to disagree with me. People are smart and they come up with great solutions for things. I just like to state that, yeah, you do lose this all these interesting features, and but if you're aware of all that and you have interesting cases that you really design with RPCs, sure, fine, they're there for you to use. It's There's a bit of a personal opinion here, but I wanted to state it anyway.
I think you kind of answered it in when you were talking there, but I just want to just highlight it just to give some people just a really solid example of I guess an alternative to RPCs. If
Hmm.
we use the example you gave of say Counter-Strike, where the player is say equipping Kevlar, if I needed that to happen on a particular tick, what would be a way that I could implement that say in Fusion?
Ooh, to guarantee on a particular tick, it would have to be based on tick input, right? So you would have to have kind of like the UI be networked, and you or you yeah, the UI would be a state, and you click on the index of that thing, and on this tick, and then on the server you would the click here on a certain index. So you would have to have an array of things that you were clicking on, something like that, or that you were choosing. And you said, I pressed it here. Because the problem is that you may ask, can I send a single Boolean for a single tick of input? Yes, you can, but that's dangerous. It's better. That's another. The problem is that you touched on a different subject, which is
Yeah.
certain things like choosing a loadout. Players want it to be reliable. So you should there is Marty, you should use an RPC for that. Now I'm arguing for an RPC for
I
that
wanted
one.
to give you the chance to see both
Yeah,
sides, I guess. Yeah.
no,
Um,
I would never do that one with a regular input. That is the exact case that you do with an RPC because you can still do local prediction. You call immediately and you change the weapon you have equipped locally with prediction immediately. So it immediately changes for your visuals. I'm not it Locally you can always predict anything you want, so you immediately change that, and then you send the RPC to the server and you're going to receive as a confirmation. And shooting has to be tick accurate, movement has to be tick accurate. That thing, it can be like, yeah, I change here and then I send it. Maybe the confirmation is not going to arrive on the same tick when you create it, because it's reliable. It may, if there was network loss, it would not be lost, it would just be delayed. So it will come a few ticks later, but it will guarantee it come.
Cool.
At least if the server could process it. So it would be rare that it would not align actually. It would normally align even with the ticks.
Mm.
But you definitely want reliability instead of tick accuracy here.
Cool. Yeah.
It's
Awesome.
it's it's funny because we have a similar concept in quantum. We have something
Mm.
called commands, which are not tick aligned in quantum, but they are reliable because they can get the server at any time. The server is going to inject them, attach them to a stream input stream tick. Whereas the regular input, which is tick accurate, can be lost and replaced by the server. So it's the equivalent of an RPC, and I would always use that for this
Yeah.
particular use case.
Awesome. Yeah. Awesome. Well, we've kind of just gone a little over time, but yeah, it was
Yeah,
definitely a very interesting conversation. I think we got through most of the questions that popped up in chat. But yeah, if there are any other questions, as I said, obviously there's multiple places to ask those, which I'm sure Anne will be linking in chat or down below this video. But yeah,
cool.
Eric, thank you so much. Obviously always a
Welcome.
pleasure to be able to chat with you.
Thanks for the
Um,
invitation. We always appreciate that.
And we do actually have another event coming up in a few weeks, which is
Yes.
being hosted on the Photon Discord.
Right,
And
you're gonna be the the invitee,
yeah,
and
we're gonna flip
yeah,
it
talk
around
about it. Yeah.
and we're gonna chat about the Fusion Pong sample that we put together.
Yep.
Yeah, hope everyone's enjoyed our chat. Well, what was I say? This evening for me. I'm pretty sure it's morning for you over there, Eric. Um, but yeah, thanks everyone,
Yep.
and
Thank you
yeah,
guys for watching. Yep.
we'll catch you all in the next video. Have a
Yep.
great night.
Bye bye.